All right, we factor trinomials using the trial and check method. So first of all, when we're factoring, um, we have a trinomial, and if you notice in this trinomial, there's no greatest common factor in all the terms. So what we're going to do is we're going to guess binomial factors, two binomial factors. So where do we start? Well, we know when we multiply, we're going to start with the first term. So when we look at this, when we look at the first term, we know that when we multiply, it comes from multiplying the first two terms in our binomials. So 2x squared, the only way I can get 2x squared is if I multiply a 2x times an x. So I know the first terms have to be 2x and x. So now the second place is the third term. So I know when we multiply the second two terms in our binomials, we have to get positive 3. So we're going to try factors of the last term. Okay, so I know I have to be able to multiply these to get 3. So say we just try 3 and 1, because 3 times 1 is 3. The last part is we got to check the middle term. And when we check the middle term comes from multiplying the smile, right? The inside 3 times x and 2x times 1. This would be 2x, or 3x and 2x. And if we combine those together, we do not get 7x, right? So 3 times 1 gives us the third term, but it does not give us the middle term when we check it. Okay, so we continue, we just erase, and we try another combination. And the numbers that we try for the last term, 3 and 1, but if they're in a different order, if I switch the 3 and 1, notice now I get 1 times x is x, 2x times 3 is 6x, and x and 6x, if I add together, if I combine, I do get 7x. So in this case, it does factor to 2x plus 1 times x plus 3. So we look for binomial factors. We start with the first term, try factors of the last term until the middle term checks, and that's our smile, right? We check that smile. Okay, let's continue. Let's try another one. Say we're going to factor this trinomial, and again, we notice that there's no greatest common factor. So we're going to try and guess two binomial factors. All right, so when we do this, the first place that we start is with the first term. And the only way I can get 7a squared, the only two terms that would give me that, is if I multiply 7a times a. Okay, so I know, I mean, this really isn't much guessing here, but if it does factor to two binomials, the first terms in those binomials have to be 7a to get that 7a squared. So now we're going to try factors of 10. And again, we want factors of 10 so that when we check the middle term, right, we're trying to get negative 19a. So if I think about that, I don't want to just have like, because it's positive 10, I don't want to just choose 5 and 2 like this, because I know when I check it, I'm only going to get positive values. So when I check the smile, 5 times a is 5a, 7a times 2 is 14a. And if I add those together, they're positive 19a. So we can kind of think of this, since the middle term is a negative 19a, then that we should use negative numbers here, negative 5 and negative 2. When I multiply negative 5 and negative 2, I still get 10, positive 10, but now my middle terms or my smile become negative terms. Negative 5a and negative 14a is negative 19a. So I know I have the factorization, the two binomial factors that give me that. So we can basically say what we have, and I know this is a lot of mess, right? If we write this out, 7a squared minus 19a plus 10 factors to is the exact same thing as 7a minus 5 times a minus 2. So we have the expanded form, 7a squared minus 19a plus 10, and we factored it and wrote it in factored form, one term with just factors. So the third example, 15x squared minus 10x minus 40, what we notice in this one is that we see a greatest common factor. So we do have a greatest common factor between all the terms. There's a greatest common factor of 5. So the first thing we're going to do is factor that 5 out of our trinomial. And if I think a distribution backwards for each one of these terms, right, 5 times 3x squared would give me 15x squared. The next term, 5 times negative 2x, will give me negative 10x. And 5 times, this would have to be negative 8. All right, so we do always want to start out, if we see a greatest common factor, we definitely want to take that out first. And now, again, we're left with, inside the parentheses, we're left with a trinomial with no common factors, right? So we're going to try and see and guess two binomial factors. And again, this is no guarantee, but if it does factor, then we're going to try two binomial factors here to see if we can't factor 3x squared minus 2x minus 8. So again, we start with the first term. That's going to give us 3x and x as our first terms in our binomials. Again, it's the only combination we could use. And then we're going to try factors of negative 8. And hopefully when we check it, when we check our smile, we're going to get negative 2x. So factors of negative 8, if we try these, and again, if it doesn't fit, it doesn't fit, but if we try these, maybe plus 4 and negative 2 in this order, and this could take some time, it does take practice, but if you notice our middle term, we would get a positive 4x in the inside, and then the outside would be a negative 6x. And if I combine those terms, I do get negative 2x. So what is our answer? So I got the two binomials for the grouped factor here, right? I can't forget about this 5 as the greatest common factor. So the factorization would be 5 times 3x plus 4 times x minus 2. Be that whole thing. All right, the last one, what we notice is here, just note the terms are quote unquote out of order, right? So they're out of order because we have a first degree term, then a third degree term, and then a second degree term. So we want to write this in what's called standard form so that the terms are written in descending degree. So we're going to rewrite this thing in descending degree first. So we're going to write terms in descending degree. So it's called standard form, and it does help us line the terms up to factor easier. So in this case, we would rewrite negative 14y cubed. That's the highest degree term. Then it would be plus 22y squared and then plus 12y. And now we're going to start factoring. So when we factor, again, we want to look for a greatest common factor. And there is a greatest common factor in all the terms. So since it starts with a negative, then that's going to be part of what we factor out. So this starts with a negative, so there's a negative 2y that's common to all the terms. So if we think of distribution backwards, that would leave us with a 7y squared minus 11y and then minus 6. So again, if you think of distribution back, we would get those three terms. So inside our grouping symbols, we have a trinomial. So here we're going to try two binomial factors. So the first term, we start with that. We would have 7y and y. So again, those are the only two terms we could use to multiply. And then we're going to try factors of negative 6. Okay, so that when I check, right, when I check the smile, I get negative 11y. So when we do this, again, this is where you would want to practice for sure, but plus 3 minus 2. If we try 3 and negative 2 in this order, we do get negative 6 when we multiply. And if we check the smile, we get 3y and negative 14y. So 3y and negative 14y, when we combine, we do get negative 11y. So our factorization, again, would include the greatest common factor of negative 2y, and then the two factors, the two binomial factors that we got by trial and check method. So this is called factoring completely. We basically continue to factor, even if we find a greatest common factor, we continue to factor trinomials down to binomial factors if we can. If we can't, then we just need to leave it. Okay.